So the goal here is essentially everything that we've been talking about today. Run stuff on our Macs, and especially for me, the constraint is I have an old M1 Pro, and it's always me trying to run local models on that. What I've realized is, look, when we try to run something as it is, it's not going to run, right? With my very little bit of Tamil that I know, I would probably say Nan Padi, Deyum Padi. So it's like you go a little bit from here towards your LLM models so that it doesn't have to do all the job, right? You kind of get halfway through the local systems, local models, and so on. And then the LLMs can come in, right? So the way I've built this is it has an escape hatch, right? I mean, this is one of the things. Let me run a few more so that you know what all works here. Okay. Add an event for tomorrow at 10 a.m. Okay, today let me do because my thing is already open. Today at 10 p.m. Add cricket. I'm just trying it out. Let the demo gods be with me.
Oh, okay.
Yeah, it did. Yes, it added an event. Or let's say, remind me to post about MLX tomorrow. Done. Right? So the reason this is super fast is because it's not running on the actual GPU. It's running on AIM. Right? I don't want to get in too much into that, but if you want me to go a little bit into the architecture, I can. But otherwise, I'm open to questions. Yeah.
Have questions later, maybe. Yeah.
You want me to do that later, right?
Yeah.
Okay, done. Thanks.
Okay. So what I did. So how many of you read archive papers or papers at free time, right? Some of them are good, some of them not so much, right? And you sometimes need to get a gist of it. And I usually use a lot of visual workflows to understand archive. So I'm like, okay, can we do it locally? So a thing called I built something called Paperflow. So it's like an on-device MLX pipeline. Here's the way I'm doing it. So I just take the PDF. I take a build an MD file, markdown file, and then use thinking and coder models to render these kinds of visual flowcharts. So there's a thing called Mermaid. I'm not sure how many of you know. So I'm basically building a mermaid and a PNG output. So yeah, I just pass it. Again, it takes a lot of time. It's not very quick. If someone has any ideas to make it quick, please shoot it to me. I'll probably integrate that. You can see, okay, I just pass the archive paper link, and it's doing. So first, thinker is there, and then there are multiple steps involved, and based on that, we are creating the PNG. Also, side note, cool thing called ASI top. I'm not sure how many of you guys know about it. So it tells you how much of your peak power and GPU power you are using. I really always want to use all my GPU. You can see it's only 2.2 watt. It's capable of 20 plus. I'm not sure how to do it. If someone knows, that would be cool. Yeah, and I can probably show the directory. So not all the paper flows were successful. Big ones are not, but yeah, the small ones which I shared. So it's a multi-step process. So I'm doing a multiple steps. First step, some output, and then refining it. So yeah, this. Yeah, you can see like sometimes there are a lot of mermaid syntax issues. I think okay. Yeah. Okay, I think this one didn't through. Yeah, so yeah, this was LLM as a judge paper, and you can see the output. And yeah, it was a small project. I think I'll probably extend it to Codebase as well. If you can build a graph for Codebase, and if at all, if I can hook it with Cloud Code, might save some tokens. Yeah. Thank you.
Accessible. Hi guys, I am Sagar. I work at C. So I was looking at a package called MLX Audio, and I was really interested in it, and I wanted to build something around it. So I built a voice assistant sort of. So a simple this I want to share. Like it takes audio from my mic, it does STT, and that then Quen is thinking which will give the answer for it, and then it will do TTS. This is all local. So all these three models are running locally. It only takes 3.5 GB of my memory, which is like really good. And these are the models I've been using. Kokoro 82 million parameters, which is like 350 MB only. And Whisper Large V3 Turbo, this was suggested by the MLX Audio team. And I'll just show a quick demo then. Just a second. Hey, I'm Sagar. How are you?
Hey Sagar, I'm Arya, running on your machine right now. I'm good, just thinking through our chat. How's it going with you? Anything interesting happening?
Can you tell me something about MLX?
Sure, MLX is the framework that powers the Metal GPU on
Everything
Apple
is
Silicon.
running locally, and
It's really
it
clever
seems really
because it has
amazing to me.
unified memory.
Like I can
Meaning the
build
CPU
so many stuff, like so much stuff around it, and being this fast just amazed me. Like MLX is so good. And I have one more thing to show. So this is like a Japanese translator. This is also local using Kokoro. The same stuff, I haven't changed anything, just some 500 MB package I had to install. I have to remind Sabesh about the iOS project I've been working on in the weekend.
私は差別に土日に入れたいをプロジェクトについて注意する必要がある。
And having a translator locally which is this fast without any internet, this amazing. This is my demo.
Hello, my name is Ashish. So I haven't made any application, but just a simple workflow to sort of fine tune the model. So I found this library MLX Tune, and I sort of wanted to sort of fine tune the vision LLM part of it. So I made a pipeline where you can give the video like a YouTube video, and it will use the frames. It will use some powerful model like sort of GPT 5.5 or something, and can create a data set, and using the MLX tune you can sort of fine tune the local model. So yeah, it's still trading, so not yet done, but I'm planning to sort of improve it to sort of see like what kind of annotation that the model has done, and you can just edit it, and sort of it will ease your way of like fine tuning the like VLM in your local machine. So yeah, that was the end-to-end pipeline, and yeah, thank you Abhik for this ASI top tool. So it's pretty good to see the utilization. Yeah.
Hey guys, so I just wanted to build something for the meetup. Like I wasn't getting too much time, so I decided like why use a knife to put butter on a toast when you can use a sword. So this is what I built. So essentially the problem statement is me just going over papers. So imagine you have a directory full of paper, like there is an agent which downloads like the top 10 new papers that are coming out every day, and you have like a whole directory of things that just keeps getting filled up. So now obviously Raycast exists, but and it has like really good indexing as well, so you can use like BM25 or like some other algorithm to actually index things. So but still I wanted to try out like, okay, what is possible with like MLX and like what we can do with it. I had been going like too deep into like embeddings model, so I had a couple of problem statements to work on embedding. So I just decided like let's try embeddings on MLX. So I'm using this model which is Quen 3 embedding 0.6b. What it does, it just indexes like the directory, like the entire directory. It chunks it into like different pieces, and then it's able to do like semantic search on like the directory. It is not that great, it's like pretty slow, but it works most of the times. So I'll just do this. 1 second. So let's say this directory I wanted to search like adversarial attack on language models. So if I just run this, takes a while. Like the biggest time consuming step is like loading the embeddings model, which is this one, Quen 3 embedding. And also, yeah, thanks to Sabesh for like this application. I can just like download it from here directly. But yeah, so this took like I think 2-3 seconds to actually find like the top 3 paper which talks about this particular topic, which is like LLMs with simple adaptive attacks and then all of those things. So I can just like go ahead and start reading this paper. So that's basically the project. So let's maybe try something else as well. Let's say fast convergence guarantee. Like this is maybe some statement that I want to figure out. So it takes few seconds, takes about 10ish or something, but it will give you like the top 3 papers that are there. So it takes about 10ish seconds. By the way, this is like a very old system. This is a M1 Pro chip. So yeah, it still works in this. I think if I run it on like an M5 Pro or something, it will probably be like at least 5 times faster as per the Apple graphs. So yeah, that's it. Thank you.
To show you something that I built. So unfortunately today just went for me with just discussions and just handling a bunch of different stuff around the event, and I did not run any agent in the background to do things for me like Kautuk did. So I'm going to be shamelessly reusing a project that was built a couple of weeks back using MLX. I'd like to introduce you guys to it. It's called MLX, and it's just a kitten that sits on your Mac OS desktop that you can chat with. So I can just text it, be like, say hi to all these MLX builders. So it just follows you around. It's always on the screen. So you guys must have seen Codex Pets, but this was way before Codex Pets. This came like, I think a few weeks ago is when I built it. Like this thing in particular uses a very old model. As you can see, it's like 3.5 35B A3B. And it can do a bunch of things, like you can just like drag it around and it can like jump, just like let it do actions, and like also like customize its behavior. Like I think you can let it it's like wander freely across the screen, let it sleep or something. I think there's a little bit of a bug with its proactive layer which I'm trying to fix, but apart from that it's just like it's just gonna do its own thing. So yeah, I think that's about it. It's fully local, fully native, and fully private. So it runs in airplane mode. That was the whole goal. So yeah, that's about it.
So yeah, I don't have a Mac. So I just took the AWS and deployed a Mac OS. And so yeah, so I deployed a AWS server on AWS Mac OS server, and then just built on top of it. So I use VS Code, SSH into it, and just try to build on top of it. So it's a small playground for the different models that I have. So for the chat, I used Llama 3.2. That is 3 billion parameters models for the. And if I normally give a chat, it will work fine. And I can also see the token per second it is generating. So yeah, and it is also updating based on the fresh tokens that it has generated. For the vision, again, I will take one image, select it. I can drop questions and it can analyze. And for the image part, I am particularly using Qwen 2, that is 2 billion parameter model. As you can see, the description of the image or whatever question that I will ask, it can answer. And also I can ask follow-up questions, whatever I want. Then Whisper Small for the transcription part. So I have a small audio clip which I can transcribe. Yeah, so it is working fine. That's all. Thank you.
Another thing I forgot to mention earlier was you can do 30 seconds full transcripts. A lot of orgs don't allow data to go to external servers. So if you want to do some transcribing or something like a questionnaire or a to-do list, you can do that. Okay, so I'll try again now. I hope it works this time.
18% in the mid-market segment last quarter, and marketing wants to put another 400K into paid acquisition, but I'm worried we're treating the symptom, not the root cause.
Okay, so it transcribes and thinks a question that what are some potential issues that be contributing to all of this, and you can just add a regenerate button so it generates questions and all of that. So kind of makes you look smart even when you're zoned out. So thank you. I'm first running the script because it will take some time to run, and now I'll demonstrate. Yeah, so I was building a system where you could convert a long form video into a short form video. So there are few steps. First, which is understanding what is the video is about, and this basically detect the face of the person and which person is speaking using a model called active speaker detection. Once these two parties done, this is mostly on the core ML side. Then we use MLX. So here we are using two separate MLX model. One is the Parquet model, which convert a speech into text, and then we are using Qwen 3.5. I started with 3.5, but it was taking a lot of time. Then I shifted to Qwen 3. So these four model basically first do few things. Number one, it identifies the top shots which could go viral, identify a hook, something like this, and in the real time it shows the transcription with the auto burn caption. Okay, so it just run, and I have a video of a Shark Tank page, so I was just going to play. This is one video which it generated.
A work of art is meant to be treasured for years and years. Even Picasso and Da Vinci have had their paintings restored to their vibrant beginnings from years ago. So why not give that same love and care to the art on your body?
So this entire thing is happening on localhost MLX and converting any long form video to short form video. I'll go to this image. It generally takes 5 minutes for a 10-minute video. I already pre-ran the face detection part and active speaker detection part, which takes most of the time because it is not running on Core ML. It is using a wrapper, Python wrapper of Core ML. So otherwise, for the ML part, for the Parquet part, for the transcription, it takes around 1 minute.
Hello everyone, I am Mike. So last week, Sabesh's blog introduced me to MLX around like 10 days ago, and I implemented what he implemented. And initially, I thought he was using a 35 billion parameter model with like 3 billion active params, but that was a false positive. Nonetheless, I implemented exactly his blog, and I got some interesting results. So the code was so the baseline model could have the token speed of like 13 tokens per second, but with dflash we were at 40 tokens per second, so a 3x speed. And similarly, surprisingly actually, on math the model performed much better, so at 3.58 x speed x. Now, I was not able to quantify why this result actually was somewhat better than Sabesh's implementation. I tried a lot of things with like sparsity as well. So just using less active parameters than the actual total size of the models. I've not come down to a core truth why this happened, but nonetheless, this is what I did. Initially, I was just a side note. Initially, I had our temperature really high, so like you can see, like the results were not as impressive here. But then when the temperature matched 0.3 to the blog, obviously the results were much better. Currently, what I think this would take from here is I'm working with a lot of accessibility trees for like Mac OS and like Electron apps. So what I think should happen is like just agents running locally on my machine, reading and capturing accessibility of like different apps, and then basically turning them into a way where I can just spawn agents to like click things around in different apps, and all of that jargon is happening like local LLMs. I don't have to paste the accessibility tree to a model or things like that. All of that happens locally. If I achieve that, like that is nirvana. But yeah, that's me. Thank you.
Hi everyone. So my name is Keshav. So before coming to this event, I don't know like anything about MLX. So after I tried with a simple idea of running a local LLM and let LLM act as a content list. Let me analyze the trade war. What shall I do and all. So I built a private local trading agent that monitors global crypto market and pings you only when like a high probability trade appears. So I am using the framework here like Apple MLX, Llama 3.2. Sorry. Llama 3.2 and Hyperliquid API and Telegram API. I'll show you the demo like which I created. So in the starting you can see like it connected to my LLM, and then like after that after in every 5 minutes it automatically check the Hyperliquid data and like tells me the decision. And like I also connected a Telegram bot through it, it directly gives me the decision over here. So that's it, just a small thing like trying to interact with MLX. So yeah, thank you. You can follow me or like we can connect on Twitter as well. It's Keshav Oja. Thank you so much.
So basically you describe a screen to the app and it will try to create that using JSON. So we'll create a JSON and then we'll basically parse it to native SwiftUI view. So if I give it an example saying a coffee shop logo with a follow button and shit like that, so let me generate and show you. Yeah.
Is it like wow?
It's kind of like that, yeah. But it's a local model, yeah.
So it's working out of the box and without any fine tuning, right?
Nothing. It's using MLX directly and Quinn 1 point, yeah, 1 point.
A suggestion here is since you have a very specific use case,
We can find it. Right, yeah.
That will be excellent.
Yeah. I mean, at this point, it's just generating a JSON, so I don't really see how you can fine tune it based on that.
You can quantify which JSONs are better, which are not.
Okay.
Which can transfer to better.
So yeah, it created a JSON, so we can see and edit it also. So it created this, and you can view it. So it's very simple. It's using SF symbols and all. Right now, you can give it support to add like modals and action sheets and all of those things. Of course, functionalities can't be there, but UI can be built like this. Yeah.
Very nice.
Yeah, that's it. Thank you.
So I made something related to macOS. I just want to fetch it with macOS these days. So everything's made by AI, and I will be also using some on-device AI for myself. I'm using a Llama 3 billion parameter model. So this thing is called Oracle. Like it is offline. The Wi-Fi is off at the moment. I'll just do some things that I want to remind myself, or maybe inscribe into notes or something, or maybe open some project or something. So let's say, so this is the Oracle. So I'll just say like, remind me to demo at CE office in 10 seconds. It also speaks, but I don't want it to blabber it out at the moment.
My voice shall echo through thy temple in tens.
So if it doesn't work, I'll probably uninstall her. In the meantime, I want to open, let's say, a project as well on Xcode or something. So I'll just say open the project Monkey.
The project Monkey Eye opens in Xcode. Enter, mortal.
The reminder did not work. Obviously, I did another command, so it hallucinated probably.
My voice shall echo through thy temple in 20s.
Let's wait for 20 seconds. Yeah, it's failing. It worked before, so why it's not working, I don't know. But maybe let me show you something. I'll show you one more thing. I said to create a nice poem and save it in Apple Notes. Let's see if it creates or not. It's not made in auto mode, so just a minute. Yeah. So the poem has been made by her. Yeah. Okay. Yep, that's it.
Basically, I tried to run the 27B Quen model yesterday on one of my Mac machines, and I realized that although it is very smart, it actually freezes my system. So I was wondering if Olama or any other model interfaces that we use on Mac allow us to control the KV cache or any such thing which can reduce the load of the model and unfreeze it. So I'm calling it the no freeze monitor. I have built this only for LM Studio right now. Now LM Studio has some hacks that you can figure out. So basically you create what I call a shim, and basically what it does is it goes, you compile it with the LM Studio and run it and try to manipulate its processes while it is owning it. So what we are doing here is, instead of us having direct API calls to the LM Studio from outside, we put a piece of code inside it, compiles with it, and helps us control it. So that's called shimming. And again, I learned about it just today. And what it does is, you're seeing this graph, which is basically the total RAM footprint of LM Studio, and the part of it which is the MLX library, active memory and cache. Okay, now I have written the notes here to explain people what this is about. What we will do here is we'll spike the RAM for the demo, and the spiking will send 10 local chats so that suddenly we will see the RAM consumption go up, and see the spikes are coming right now, right? So how do you create a hero? You create a hero by first creating a villain. So this is a villain we are creating, which is basically the spiked RAM, and then we'll get the hero, which is the shim that we inserted in LM Studio, and we'll get it to clear the improve this particular function that we have access to, which is set cache limit and clear cache. So we spiked it, and now this is the moment of truth. We'll try to put a limit of 100 MB RAM, and we should see a drop. Maybe now or in some time, let's see. So the apply runtime limit has happened, so some drop should happen. Oh, it did. So that's worthy of well done. So well done to the LLM. The idea here though proves something else, that it is not enough that the ML model, the LLM runs on your local machine, it should run in a way such that you can control its excess from affecting your overall device experience. And that is the main theme of this project, that hey, can I have controls on my inference interfaces like local LM, like Olama, which can help us act in case it is interrupting our device experience itself. And yeah, this is what it does. Let's try again if it drops further. And yeah, that's what happened here. Cool. So shimming is new to me as well. I just learned about it today, last couple of hours. But again, it also tells you that some of these tools, though they are sophisticated in the sense that they have been built by big companies and a lot of teams are running them, they offer some opportunity for us to customize them for ourselves. And ideally, I think that is what informs their roadmaps as well. Cool.
What's the trade-off? There has to be some trade-off of
So the thing is, if you remove the cache, then your ongoing conversations will stop. But then your system will stop freezing. So basically, this is more like a panic button that, you know what, the local inference that you're saving dollars on is not letting you work. Okay, and in that case, press this panic button. More importantly, monitor this. I think the key thing to note here is, if we can monitor this, which this has proved. So basically, we are able to, the MLX library itself offers a lot of tools to monitor the RAM and the cache. And if that monitoring is done in the proper way, you can actually preemptively stop it from interrupting your total experience or jarring your total experience. So I think because the running of local models is not really matured yet, the product managers at these companies have not thought of these features, that you need to preemptively stop or reduce your cache or RAM imprint. Otherwise, you'll not let the person work.